Hi guys, we are continuing with our Leetcode and today is a new task. So let's get started. I'm sharing my screen. All right, and today is a task about minimum remove to make a valid parenthesis. So we're given some string with parentheses, and our task is to remove the minimum number of parentheses in any position so that the result parenthesis string is valid, and return any valid string. Formally, a parenthesis string is valid if, only if, its empty string contains only lowercase. Its empty string contains only lowercase characters, or it can be written AB, like concatenated with B, where AB is a valid string, or it can be written as A, where A is valid string. All right. So let's try to understand the question. So we have some string that I believe contains of lowercase English letters and also parentheses like this. Okay. Also, I believe that our length, that's important that it's from 0, and the maximum string length would be, let's say, 10 in 9 power. So our task is basically to write a valid string. So to remove invalid parentheses. And to make it more clear, let's do some examples. So the first example can be like this. We have some string, then we have parentheses, we have string here, and we have string here. So this string is actually valid. So the result would be as following. But we can have something like this. And in this case, our string should be in this case, our string can be like this, or another case, it can be like this. So we have both valid strings. If we take this example, so we can see that we have, for example, this invalid string, so we can delete it at the end and make a valid string like this. Okay, so about solutions. So the first solutions that come to my mind, we can use a stack to track of validity of string. So let's say we have such string, and then when we go through our array, we are doing the following. So we are doing the following. We are iterating through our string, and if our element is not parenthesis, we just add to result array. So let's say we have result array, and we have also our stack. So if this character is not parenthesis, then we just add to our result array. Then if we have an empty open bracket, then we what we can do, maybe we can not put on the result, maybe we can put on the stack. Okay, and what next? No, I think we should put on the result. Okay, so what next? Then we should put on the stack we should put on the stack we should put on the stack open one, then we have another open one, and when we have close, we just remove it from the stack, and if we have close, we also not put it on the stack. So actually, what does it mean? It means that yeah, it's interesting. So yeah, because for example, we can put everything on the stack, like here, open, then we have T, then we have again open, and so on. But we should remove it. We should remove it somehow. Yes. So maybe what we can do, maybe we have like stack with parentheses, and in this stack with parentheses, we will store not, like we can store open brackets, right? But when we have like open bracket, yeah, when we have open bracket, so we store also indexes. So we have like current index, that would be 0. Then, yeah, I see, for example, yeah, I have current index, that would be 0. Then I see, okay, so, and I have also my result array. And yeah, so then I go like, okay, I see. I have L, and I put on my result array, and I increase my current. Then I have E, I put it in result array and increase my count. Then I have another E, put it and increase my count. Then I have this open parenthesis, right? Then I have this open parenthesis. And what I'm actually doing, I should yeah, first of all, 10 in the fifth power. Okay. Okay, let me think. So if I have open parentheses, then I can put this open parenthesis like here. Like open is equal to 4. So it would be like pair. Yes, it would be like pair. Okay. And then when I have close one, I see that it's open one, so I can put my close one. And yeah, I put them, like I increase it. Then I have like T, I just put T and increase it. Then I have open one, so I also put and open one with 6, then I have like C, then I have closing one. And here I see that yeah, I should remove probably this from here and to not put the closing one. Yeah, but if I remove it, then I will lost it here. So yeah, so that's a problem. So maybe I can have like also the map of parentheses where I should put this parentheses as well. So, for example, when I have like open parentheses, right, open, then again open, and now I see like closing on the let's say 8 position, right? So when I see closing on the 8 position, I put into my map. I put into my map like on 6th position. I have open one, open parenthesis, right? And on 7th position, or on 8th position, I have closing one, and remove this from the stack. Then again, I go like next. It would be O. I increment it. Then I have closing one, and now I remove like on 4 open one, and on 10 I have closing one. It's something that I should add. Then I add like D, it will be 11, E, it will be 12. Then I have closing parentheses. By my stack is empty, so I actually don't add this element to the stack. Okay, so what I'm doing next, I'm doing the following, and then I have my result array, and I know that I should on index 6 I should put like this parenthesis, and on index 4 I should put this parenthesis, and so on. So I'm actually going one by one. So I go like from 0, 1, 2, 3, but here it's okay, so it will be 1, 2, 3, then 4. Yes, then I put this parenthesis, then I go like 5, 6. So after 6, I put, yes, 6, it would be here, and so on. Okay, so let's try to implement. So this solution actually works with time complexity of n, because I just iterate through every element. I think 2 times, and space complexity would be also of n, because I have stack and I have map. It would be 2n, but actually it's n. Okay, so let's try to implement it. So what I have my stack of character, new stack. Okay, then I have map. Map, if it would be integer and character. Character map, new hash map. Okay, then what I'm doing, I'm actually going through my every value in size I++, whereas char at I, it will be char C. and if, and I also have, let's say, my string builder, new string builder. Okay, so if my character is not equal to open parenthesis, or my character is not equal to closing one, then I just add to my Spring Builder append this character. Else, here I have this thing. So if my character equal to open parenthesis, it means that open parenthesis, I should always add to my stack. It doesn't matter if it's stack empty or close, I should always add it. So it would be like stack and this C. Else, so when my C is closing parenthesis now, and if stack is empty, if stack is not empty, and stack peak is equal to open parenthesis, right? Okay. Here in stack, I would not only add character, but I would add two things. So I would add character and its index, actually. So it would be kind of pair of elements. So yeah, with different values. So I should create some, let's say, here record pair, and here I would have like character. I can have like this, and also position. Okay, and here when I add this new pair, it would be character and also position I. Okay, and here when I pick, I should check with C. Because C should be equal to open. So if it's closed now and the previous was open, I should add to my map. I should add this. So first of all, I do stack pop. It will be pair, and into my map, I get like pair I and pair C. Okay, so with this iteration, I actually make my map and make my string builder. So now I have string builder to string. So it would be my, let's say, char string. So here it will be only characters that I should add. And I again iterate through this character string. So from I equal to 0, I is less than character string. Okay, so I equal to 0 and it's less than character string with size, then I plus plus. Then after this, I am doing like character string char at I. So I'm taking this character And what else? I'm checking like if and I should have like string result array. String builder, let's say new string builder, it would be our result. Okay, and I should return this string builder to string as result. And here I can check like if map contains key with I, then I should do like append map get I, and also under this map I should like put let's say by I would put like null. Okay, so if map contains I would put this by I. Okay, and here then I should also append my C, my character. Okay, and here, like in also situations when I should iterate through my here maybe I can remove even. I can remove. Yeah, I can remove from map this element. And here, like for example, if I have string only with parentheses, right? So for sure, I should also iterate through map, like map case set, and here it would be k. And yeah, so I have sb char sb. So yeah, sb it my results. Wait, yeah, so here it should be result append. Yes, and here is also result. Here it should be result append map get key. So here's a problem. Here's a problem. Why? Because case set actually returned me not sorted, not sorted array, right? So I should do another way, I think. I should do another way. I should do it. Yeah, I should probably do it another way. I should iterate like once again through my this string as size. Okay, as size. And here I should do the following. So if my map get I is not equal to null, I should do result append map get I. Okay, and now yeah, its code is quite verbose. So now let me check. Yeah, let me check with, for example, I have such string, right? Only with parentheses. And yeah, let's run it to check that it compiles. Okay, it's not compiles. String builder. Yes, it should be string builder. Let's compile it. So what's the problem? Size, maybe length. Compile it. Okay, so here I have map put, not add. Here I have, yeah, map put. And okay, char lengths. And here again, lengths. Okay, so it's compiled, but yeah, result is incorrect. I have output, and yeah, in the end, I miss this one. Here, I add this element, and here my output would be the following. Okay, so let me check this example. Let me check this example. I think we can check this example. Okay, so what I'm doing, I have my character, right? So character is not equal, so I'm not appending it here. But here I have, I'm checking like if it's open parentheses that I'm like adding to the stack. If it's not, so now it's closing and stack is empty. So I'm not going here. I'm not adding closing parentheses here to the map, right? So I'm interested in, let's print what we have in the map at the end, okay? So in the map, we have nothing, okay? So what we go next? Next, we have our result. Our char string will be empty because we are not append anything. So we are not going to this loop, but we go here and our result, where is it? Result. Yes, result. To string. We have our char string. It's SB to string. Okay. Wait a minute. Yes. So here I'm not append. Yes, I'm not append to this char. So this length would be 0, not going here. But this S for every my character, I'm checking. Okay, if I get this element, then I append to my results. And then result is string. So I'm wondering why I have this in the output. Like I should not have this in the output. So let's check this result. The result should not have it. So it's really strange. Here, yeah, here I have this in result. Okay, how can I append this? Because, so for example, char set, let's print also what I have in char set. Okay, so that could be the problem. So This string builder appends all elements here. So if here should be end. Let's check. Okay, so now it works. Now here, yes. So here we have what? Here we have 3. Yes. And here we have the following, like we add it to the stack on position 3. Then we have closing one. And we check like stack is empty. Right? Stack is empty right now. Oh, not empty. And stack pick. So we pick from the stack our element, and it's like open one. And currently we are on the closing one. And if it's open one, then we pop it from the stack pair. Yes, pop it. Yes, and also we should put our current element. So it should be I with closing one. Yeah. Okay, so we have 0, 1, 0, 1, 2, 3. This one we actually missed. Like we should like skip it. And yeah, so that's we should also do the following. If we are skipping some element, we also like have like skip count, and it would be 0. And skip count is actually going like where it's going here, I think. Else, and here it would be skip count plus plus. Here would be skip count 1. So should it be skip count? Yeah, let me think. Yes, skip count. And then when we put in the map, I think, yes, we should do minus skip count here as well. Let's run it. Yeah, the problem here is that we have skip count how many? Only 1, right? So C is correct, but D is not correct. And So here we put C, and then we have D. And then we have D. Yeah, I think this skip count it's not correct actually. It's not correct. Let me think one more. Let me think one more time. Yeah, this indexes is not correct. So maybe I just need to point which one I would remove actually from my result. So for example, when I iterate through my string, right? Here I would have like a set of integer to remove. And I should not include it in my result. And to remove, it's actually something here I should like add to remove my I, and it's mean like I'm going through this element, and so for example I meet this character, it's mean okay, I should remove it. Then I add this one, I add this one, then I have like closing one, so I stay. But I also can have like situations like this one, and I should also remove them. So so it's good that I'm in stack I'm leaving these elements, these pairs I mean, and here probably I don't need a map. Actually I don't need map, so I have stack and set of to remove elements, and then I have my result, yes, to string. Probably I don't have this one. I don't have this one. So if it's on open, yes, and I just add it to the stack always. If stack is not empty and it's open, I also add it. I'm pop from the stack. And otherwise, I mark is to add remove, and then I have my stack, right? So what I'm doing next, I'm going while stack is empty, not while stack is not empty, then to remove, I'm adding stack pop, and I'm popping I. Like to remove, what should I remove? And then I have my result, I don't need this one. Also, I think I don't need this one. I go one by one, and then I check if to remove contains false I element. Then I have my result. I append my schar at I position. And then I have my result. And let's check. Okay, submit. Okay, nice. So it's done. So yeah, basically the logic is to have to remove set, and actually here we even can write it more elegant, like with with one if block. This one, let's format code. Okay. Okay, so here we add to the stack. Here we like just pop element, and we can check like if stack else if, and move this one here. So else if we pop element from the stack, else it's like invalid. So we just remove it. And yeah, let's move this result string builder here. Okay, so have a stack, then to remove, and yeah, then one more time. So time and space complexity is the same. Okay, so here probably I missed something. All right, so let's, yeah, then our previous implementation is correct. Okay, so yeah, that's all for now. Thank you very much and have a nice day.